Hi guys, today in this video I'm going to teach you how to make an electric generator from a 220 volts drill machine. Now this pulley that you see, I got it from Bangwoods. Link for this will be provided in the description. The bore size of the pulley is 8 mm, so I will need a shaft of 8 mm size. Here as you can see that I have connected the drill machine terminals to the clamp meter, and as you can see, when I run the shaft it generates around 1 to 1.5 volts DC because of the presence of residual magnetism. Now let's connect this LED and test if it generates enough voltage and current to light it up. Okay, but as you can see that it is not lighting it up because the presence of magnetic field is very weak. So guys, as you saw that the setup worked pretty smooth. Now what I'm going to do is connect the multimeter in the DC mode, voltage measurement mode, and then I'm going to run the motor to run the drill machine and measure the generated voltage. As you saw guys, that it generated around 5.5 volts DC without any excitation, external excitation, with just residual magnetism. Now I'm connecting a 3 volts battery with a 12 volts bulb in series to check if it is going to excite enough to light up this bulb. The bulb did not light up at all because the internal resistance of the drill machine is very high as around 70 ohms, because of which the circulating current was very less. But if we compare the winding resistance of the washing machine motor with this drill machine motor, then you will see that the winding resistance of the washing machine motor is very low as around 6.6 ohms, means 10 times less. Therefore, the current flowing through the washing machine motor windings is going to be 10 times more with 3 volt cell. So for that reason, I'm going to use this 12 volts 5 ampere supply to excite the winding of the drill machine. So guys, I have turned on the 12 volt supply, and as you can see that it is glowing the bulb at full 12 volts potential. So let's connect this 12 volt supply in series with the drill machine and the 12 volts bulb. And after that you will see that the bulb is still not glowing even a little bit. No glowing filament at all. Let's measure the current with the help of a multimeter to see the current flowing through the bulb and the windings of the drill machine. The current flowing is only 0.18 amperes, very less. Bulb still did not glow, which means that I will have to increase the voltage of the supply further, excitation voltage. So I'm going to remove the 12 volt supply and replace it with the 32 volts DC supply. Let's connect it to 220 volts, and as you can see that the bulb is glowing, not at full brightness, but yeah, a little bit, around 4 or 5 volts. As you saw that the bulb completely turned off when I ran it. Let's try it by reversing the polarity. It's running slowly, but the brightness of the bulb has increased considerably. This means that it is indeed generating electricity. I am removing the rubber belt and trying it with hands because the rubber belt is going to get burned out. You can see when I turn the shaft of the drill machine, the bulb glows a little brighter than it was initially when connected in series with the 32 volt supply. So guys, here as you can see that this is a 220 volts drill machine which I'm going to use to run this angle grinder at high speed. And I have used the same setup as I did with the washing machine motor. I've connected this 3 volts lithium ion battery pack in series with the 12 volts bulb, and all of them are in series with the angle grinder. Now this setup is going to work much better because the power rating of the drill machine was only 300 to 350 watts, but that of the angle grinder is 850 watts, because of which the internal coil resistance of the angle grinder is going to be much lesser, so it is going to circulate huge current even with such a small battery. Okay. Hi guys, you are watching channel Mr. Electron. This what you see is a BLDC motor from an old Xerox photocopy machine, and this is a 10 mm pulley, but it is not fitting the shaft of the BLDC motor, so I'm using this rubber sleeve to place it firmly inside like this. As you can see that the pulley is perfectly placed, but it is still a little wobbly. So let's place this screw here to make it more stable. Yeah, and now it should perform perfectly nice. And guys, I got this drill press from Banggood's, link is in the description. So guys, your question for today is, can a 10 watts DC motor generate enough electricity to start a 1000 watts DC motor? As you can see that I'm using L brackets for making a base stand for this motor, and I got these brackets also from Banggood's, and link for these will also be provided in the description. You can check them out. Okay, and this cordless drill is also from Banggood's. It works really nice. You can see that the stand is perfectly made. Now I'm going to test it at super high speed with the help of this BLDC motor controller, link for which will be provided in the description. As you saw that the speed in the motoring mode was super high, let's test it as a generator now. Here I am using a car indicator bulb, and as you can see that it is glowing really bright. Now let's turn off the lights and test it again, and yeah, it is bright enough. Now let's place it on the bicycle generator stand. I have this aluminum base stand on which I am going to place this BLDC motor, which I am going to use as a 3-phase electric generator AC with a power generation capability of 240 watts, which is 24 volts and 10 amperes AC. Now to convert that 3-phase AC into DC, I am going to use this 3-phase rectifier. Let's measure its generated voltage, pointing the meter towards 200 volts DC mode. As you saw that the maximum generated voltage was 19 volts, let's measure the current now. The current was only 3.64 amps because the friction between belt and pulley is very less. So we will have to increase that friction with the help of this bearings setup that I'm making now. Here what I'm going to do is connect the two bearings in series with each other without anything in between, and this bearing setup is going to press the belt more and more towards the surface of the pulley, thereby increasing the contact area of the belt to the surface of the pulley and thus increasing the friction between the belt and the pulley. This method is going to prevent the pulley from slipping when it is loaded heavily. This idea is going to serve 3 amazing advantages. The first is it is going to increase the friction between the pulley and the belt. Second, it is going to increase the lifespan of the belt, which would slip against the pulley and wear off with time. And the third, we are only going to need one belt instead of the two, and we will get double power out of it. As you can see that the setup is working smooth and the rectifier has also been placed on the base stand. Now I have connected a 250 watts bulb load to it for testing. Let's see how it performs. Now I'm going to add an additional bearing to the two bearing set to force the belt to stay in one place instead of sliding off the pulley. You can see that I have placed few washers in between the two bearings to create a pulley like shape, and the belt is placed in between, and now it works really well. Now guys, let's measure the generated amperes with the help of this Must Tool clamp meter, link for which has been provided in the description. The generated current, as you saw, was somewhere around 6.02 amperes, and it also depends on the load. Higher the load, more is the current. Guys, this is another product that I got from Banggood, and this is a multimeter or energy meter. Okay, let's open it. It works on DC only, and it can display voltage, current, power and energy, and it also has the saving memory. The circuit diagram has been drawn, and the maximum voltage rating range is 5 volts to 100 volts and current from 0 to 100 amperes with a heavy shunt resistance and precise display. So guys, as you can see that the bicycle generator project of mine is fully complete now. To the rectifier output terminals I have connected this shunt resistance which is feeding signal to this meter of mine. Okay, and this meter is going to display the generated voltage, current as well as energy, and I have used the simple telephone wire cables that contains 4 wires which are needed to be connected. Here you see 4 wires, they work perfectly well. Also guys, I have changed the output wires. I was using red and blue one, now I am using both of them as yellow, and I have connected 100 watts incandescent car headlamp bulb. Let's test it. You saw on the display the generated current was around 9 amperes and the power was up to 104 watts. Now I have connected a 35Ah battery, car battery, and it is very discharged, displaying only 6.29 volts. Let's run the generator and charge it. You can see as displayed that the charge on the battery has increased, although it is reducing because I ran the bicycle for a very little time and it was not enough to charge it fully, of course. It is showing 8.96 and decrease. So guys, the question for today is, does any of you has a clue where I got this motor from? Also guys, I found this other water pump and I believe that the pump part of this setup is a little bigger than the previous one, so I might upgrade it with this one. You see, although it has been repaired, you see it's broken. So yeah, if the blades of it are like metallic, then I'm going to upgrade it. Otherwise, if it is going to be still plastic, then it's not worth doing that. And guys, I was using my solar panels to run this water pump that I have made, but as you can see that the weather is a little cloudy, because of which the output pressure was a little fluctuating.